Hi everyone. Today I'd like to talk to you about defining motion in physics. And by that I mean let's talk about position and what it means to be in motion. What it means to have a distance or a displacement, to have a speed or velocity, and what acceleration is. So to start with, we'll focus on understanding the difference between position, distance, and displacement, and then we'll understand the difference between speed and velocity. We'll look at solving a couple problems using average speed and velocity, and then we'll tie it all together as we calculate distance, displacement, speed, velocity, and acceleration. So, position. An object's position in one dimension we can assign to a position on a number scale. We can set the zero wherever we want, we can set whichever direction we want to be positive as long as we're consistent within that problem. So if I set my current position where I am right now, and I call that 0, and I call out in front of me the forward direction, if my dog was 2 meters in front of me, my dog's position would be at 2 meters. I would say my dog's position x is equal to 2 meters. When position changes, an object travels some distance. How far you've gone is your distance traveled. The more position changes, the more distance is traveled, of course. Distance is a scalar, and its standard unit of measurement is the meter. So a sample problem, if we have a deer that walks 1,300 meters east to a creek for a drink, then walks 500 meters west to the berry patch for dinner, and then gets scared and runs 300 meters west when it's scared by a raccoon, what total distance did the deer travel? Well, the deer traveled a distance of 2,100 meters, or 2.1 kilometers. 1,300 meters plus 500 meters plus 300 meters. And that's a scalar. It doesn't need a direction. It has magnitude only. Displacement, on the other hand, is a vector which describes the straight line from where you start to where you finish. In some ways, it's sometimes called the position vector. It points you from your origin to that final point. Displacement, which we often call x minus x0, where x is your final position, x0 is your initial position, can be measured in meters. And sometimes you'll even see that written as the position vector as an S with a little line over it showing you that it's a vector, or sometimes even R with the line over it showing it's a vector. So it has several different symbologies, and it really depends on exactly what course you're taking and what book you're trying to get along with. In any case, if we have a problem of a deer walking 1,300 meters east to a creek for a drink, once again, our deer is going to go in a different direction. It's going to go 500 meters west then to a berry patch for dinner before deciding that he's going to go 300 meters west when scared by a raccoon. What is the total displacement for the deer? Well, to find that out, we go from our starting point, our origin, to our ending point and draw a straight line from start to finish. That red arrow is our displacement vector. The length or magnitude of that displacement vector, if we went 1,300 meters east, then 500 west, then 300 meters west, must be a total of 500 meters. So our displacement vector must be 500 meters east.